Quick stop, DB data and DB schema. Before we proceed further with the release stage, let's learn the difference between DB data and DB schema. The database, DB, is a set of virtual containers called tables with special relationships between them. Let's look at the table CC Transactions, Test Portal, DB, Data, CC Transactions, where we store data about the success or failure of each attempt to use credit card for purchase. The CC Transactions table has 4 columns: ID, Result, User ID, and Order ID. After each new transaction, when the user attempts to buy a book, a new row is inserted into CC Transactions. These rows are called DB rows, DB records, or simply rows or records. The value of the column ID is populated automatically with each new credit card transaction. The value of the column Result consists of 2 concatenated values: internal ID of a credit card, for example, 1 for Visa, and success code of transaction, 0 for success and 1 for failure. For example, 10 means that the transaction with Visa was successful. By the way, you can see all the credit card IDs here at Test Portal, DB, Data, CC Types. The values for columns User ID and Order ID are equal to the corresponding IDs from table users: Test Portal, DB, Data, Users, and Orders, Test Portal, DB, Data, Orders. So if a purchase was made by a user whose ID equals in the table Users, the values of User ID in CC Transactions for that user will also equal brain positioning. Values under the column ID in tables CC Transactions, Orders, and Users are called a primary key. Each primary key is generated automatically, and it's never repeated under the same column. If we use a primary key in another table, we call that key a foreign key. For example, User ID under CC Transactions is a foreign key. A DB table can contain only one column with a primary key and as many as needed columns with foreign keys. Let's create one successful transaction, one failed transaction, and look into the DB. Please note that Test Portal pages that show DB data are updated once a minute, so you might wait up to 60 seconds before your data is available on the Test Portal. Keep refreshing the page until you see your data. Let's start with a successful transaction. Please note that our order ID 263755 is stored in the table CC Transactions under the column Order ID and in the table Orders under the column ID. Our user ID 282507 is stored in the table CC Transactions under the column User ID and in the table Users under column ID. As you can see, the transaction was successful, hence the value of the result column equals 10, and order ID is populated inside the table CC Transactions. Now let's create a failed credit card transaction. We'll use invalid data instead of a credit card number. Please note that in the case of a failed credit card transaction, the value of order ID inside table CC Transactions equals 0 because no order has been made. As you can see, the transaction has failed, hence the value of the result column equals 11 and order ID equals 0 inside the table CC transactions. Let's proceed. The DB schema is about containers, tables, and columns, and their relationships. The DB data is the content of these containers. So, if we add a new column, time created, to the table CC transactions, or create a new table, we'll change the DB schema. If we do any manipulation with the content of the table CC transactions, for example, we create a new transaction that would insert a new record into CC transactions, we'll change the DB data. The best analogy is this. The DB schema is a plastic bag. The DB data is water in this plastic bag. The DB schema has its own versioning, usually starting with 1 and incremented by 1 with every schema modification. So if we have a DB version 34, then after we modify the DB schema, for example, we add a new column to CC transactions, we'll have DB version 35. The DB schema is created or modified manually. For example, a developer runs SQL statements, or by creating and running SQL procedures which incorporate those SQL statements. SQL statements and procedures that modify the DB schema must be checked into the CVS. People who work professionally with databases are called DB administrators, or DBAs for short. Let's look at DB schema version 34 of ShareLane.com. Test portal, DB schema. ShareLane SuperDuper Inc., the beginning. Let's imagine that our company, ShareLane SuperDuper Inc., was created to sell books via the internet, and it has just received its first round of financing. In the beginning, we have two programmers, Billy and Willie.
CEO Jean-Baptiste Emmanuel Zorg,
further referred to as Mr. Zorg or the boss. Two desktop computers with Windows OS for programmers, MacBook Pro for Mr. Zorg. One server known as the Star with Linux OS for the development in test environments. By the way, on the Star we have 5 environments. Old.ShareLane.com. Here we have the same version that's on the production machine. If prod has version 1.0, this environment has version 1.0. Main.ShareLane.com. Here we have a version of the coming major release 2.0. If code for that release has already been frozen for testing. By the way, we've just released version 1.0, so at this point, www.sharelane.com, prod, old.sharelane.com, and mainsharelane.com have the same version. dev.sharelane.com. Here is where programmers do integration between their code before that code is pushed to main.sharelane.com. Any kind of version can be here. Billy.sharelane.com. Billy's Playground. Any kind of version can be here. Willie.sharelane.com. Willie's Playground. Any kind of version can be here. Let's see the complete list of ShareLane environments. Test Portal, Release Engineering, Environments. The project starts. 1. We register the domain sharelane.com. 2. We rent the server for the production environment at the hosting provider. 3. We unite all our local computers, Billy's machine, Willie's machine, the Star, and Zorg's laptop onto our intranet. 4. The programmers start working on the code. As you already learned, Classic Web Project Architecture has these 3 components: Web Server, Application Core, DB. By the way, because we've just started, all of our test and development environments will reside on the Star. Please note that each of these 5 environments will have its own web server, application core, and DB. ShareLane architecture. Now let's talk about ShareLane.com architecture in detail. 1. Apache Web Server. The name Apache comes from A, patchy because of the enormous number of patch releases applied to this free software. However, those patch releases did well because Apache is a very reliable, high-quality software package. In the Apache directories we store HTML and JavaScript files. JavaScript code, or reference to the file with JavaScript, is incorporated into the HTML code, and it serves many purposes, from enhancing the user interface to checking web forms. On ShareLane, we have a JavaScript file timer.js that's called during user login. Let's look at the source code of login.py and find where timer.js is linked. Test portal, application, source code, login.py. By the way, the advantage of using JavaScript to check web forms is that this check, for example, a valid format of email, for example, no @ats, happens on the user computer rather than on the production server. This way we can reduce the load on the production environment. In addition to HTML and JavaScript files, we also store image files or simply images in one of the Apache directories. Let's find image logo.jpg on ShareLane store page. Two, our application core is written in Python. Python scripts reside in a special directory in Apache called CGI-bin. You can look into the actual software code of the application core here. Test portal, application, source code. 3. For a database, we use MySQL. In the DB, we store data about users, books, orders, and other things. You can see all the current data inside ShareLane DB here. Test portal, DB, data. As our software development begins, the first problems emerge because neither Billy nor Willie has experience in version control. For example, they can simply delete each other's work if they save a file with the same name in the same directory. So if Billy copies his version of register.py into directory, and then Willie copies his version of register.py into the same directory, Billy's version is overwritten and gone from it, so Billy, Willie, and Mr. Zorg make a historic decision to use CVS. Using Control Version System. By the way, the great news is that CVS is free, and it came pre-installed on the Star. Here are some details about this CVS. 1. Versions of each file are stored in a CVS repository. We can retrieve the needed version of the file from the CVS repository to view or edit it. This operation is called checkout. We can place a new version inside the CVS repository after editing of the file. This operation is called commit or check-in. Here is how we do this. Add new file to CVS, CVS add register.py. Check out the latest version of register.py, CVS CO register.py. Commit the new version of register.py, CVS CI register.py. 2. When we commit a new version of the file is considered to have a new version even if we deleted a single character like pound. We don't need to change the file name. CVS automatically assigns a unique version number to that particular version of the file. During commit, CVS allows us to put comments for this specific version of the file. During commit, CVS also stores the version number, comments, and name of the person who did the commit and the time of the commit. So not only can we see all the checked-in versions of the file, but we also can see all of that information for each version. Lesson recap. 1. A DB table has columns and records. 2. Under each column we store a piece of data. 3. New rows in the DB table are called DB rows and DB records, or simply rows or records. 4. The primary key has a unique value under the same column. 5. The foreign key is data that serves as a primary key in another table. 6. The DB schema is about containers, tables, columns, and their relationships. The DB data is the content of these containers. 7. SQL statements and procedures that modify the DB schema must be checked into the CVS. 8. Each environment has its own web server, application server, and database. 9. JavaScript inside the web pages can be used for client-side processing, so using JavaScript makes the application faster for users and unloads the server. 10. Executable scripts, for example register.py, are stored in a special Apache directory, CGI-bin. 11. Using version control software is a must because we can store all versions of the file and don't delete each other's work. 12. We use the CVS add command for adding a new file to the repository. 13. We use the CVS checkout command to get a file from the repository. 14. We use the CVS commit command to check in an edited file back to the repository. 15. CVS records metadata, who did commit, comments, time, etc. 16. CVS assigns unique version ID to each version of the file in the repository, even if one character was changed after checkout and before the commit.